Here is an explanation for the answer to final exam, question number 25 in Physics Demystified, 2nd edition. If you have the printed book, please refer to page 518. I'm also going to get into a little bit of a mistake that occurred in this book on page 112, which deals with the mean life of a neutron. But first, let's get to this question and the correct way to solve it. As things turn out, whether you use the slightly incorrect definition on page 112 or the correct definition that I'm going to provide you with now, you'll get the same result. The same answer applies here. Isolated neutrons have a mean life of approximately 15 minutes. Imagine a group of 8,192 neutrons floating around in outer space, not interacting with each other or with anything else. That means they're isolated. Roughly how many neutrons should we expect to find remaining in this hypothetical swarm after one full Earth day has passed? Well, the mean life of a neutron is the average length of time that we can expect it to survive in isolation. If we have, say, 1 million of these things to start with, well, let's just say some large number, 1 million of them to start with, and we wait for 15 minutes, and these are all isolated, we can expect that we'll have a certain number of them left. But according to what I'm saying on page 112, it would be 500,000, but that's not correct. That's the half-life. 500,000 would be the half-life. The mean life, which is about 15 minutes, that is correct, we'll end up with 1 over E. We should expect, in a large number of situations like this, that we would end up with 1 over E of them after 15 minutes. Well, what is E? E is the exponential constant, which is an irrational number, roughly equal to 2.718. 1 over E is equal to roughly 0.368. So, after 15 minutes, one mean lifetime here, we should expect to have 1 million times 0.368, or about 368,000, give or take a few, because this is a kind of a random process. Well, we're starting out with 8,192 isolated neutrons in this question. After 15 minutes, we should expect to have this many. After 30 minutes, we should expect to have that many. We multiply by 0.368 again. After an hour, to the 4th power. After 24 hours, we would expect that we would end up with 24 times 4. We would have 96 15-minute intervals taking place in 24 hours, so we would cut this to 0.368 of its original value 96 times. Well, you can work this out, 8,192, and this is approximate again because the mean life of a neutron is approximately 15 minutes, but it doesn't take a whole lot of rocket science to figure out that this number is going to be, it's going to be a tiny, tiny number, something like 10 to the minus 40-something power. So after a full day, we shouldn't expect to see any neutrons left. I mean, 8,192 divided by 10 to the 40-some power, for all intents and purposes, is 0. So the correct answer to this problem is E. None. Or in an exceptional case, maybe 1. Well, that'd have to be a mighty exceptional case. We shouldn't expect to find any. Now, going back to page 112 where the error is, I describe the nature of this mistake in a little bit of detail on my website. Go to sciencewriter.net. And then you'll find a page with a weird looking little thing in the upper left hand corner. That's an artist's rendition of a neutrino you'll find up there. Oh gee, I'm going off the beige board with this. Well, it looks like a little thingy with a ring around it or something. sciencewriter.net. You'll see a bunch of links. Go down and hit the link that says mistakes. Mistakes. Then hit the link for Physics Demystified, 2nd edition, and you will find a description of this mistake. I apologize for these mistakes, but when you write dozens and dozens of books and millions of words, my excuse is you're bound to make a few. And I think, in my opinion, it's better for me to bring these mistakes out in the open if I find them, or if you find them, you can email me. Go again to the website. sciencewriter.net, and you'll find a link for my email. If you think you find a mistake in my book, in any of my books ever, let me know. Email me, and if you're right, I'll put it up on my mistakes page, so that rather than let them simply lie like sleeping dogs that'll bite you in the butt someday when you're not looking, you'll at least be able to see the dog growling. It's always been my policy to point out errors. We all find textbooks with mistakes in them. I think it's the best policy to point them out when I find them, rather than try to pretend that they don't exist. Once again, the correct answer to this problem is E, and if in fact you used the incorrect definition of mean life that I provide on page 112, you'll still get E for the answer here. Instead of raising 0.368 to the 96th, you would end up raising 0.5 to the 96th, but that's still, for all intents and purposes, 0. So, good luck on the rest of this exam. And if I find any more mistakes, I sure hope I don't, but if I do, I will point them out and explain the corrections in detail for your benefit. Stan Gibilisco signing off until question number 26.